When you walk into a house, you don't really need a manual to understand the architecture. Like, you intuitively grasp that a bedroom serves a completely different function than, say, the front porch or the garage.
Right, your brain just sort of maps it out instantly.
Exactly. You cross the threshold and you just know the distinct zones. But imagine handing a builder a blueprint that meticulously details every single bedroom, the living room, but completely omits the front door or the driveway or the backyard.
The house would just fail. It wouldn't work at all.
It fails. And today, for you, our curious listener, we are looking at a software project that accidentally did exactly that. But, not with a physical house. This happened while trying to teach a computer how to read a book.
Yeah, we are diving into a really interesting set of technical notes today. They're focused on Haskell programming. And the core challenge outlined in these notes is digitizing standard text files and parsing them into perfectly structured ebooks.
Which sounds straightforward, but it's really not.
No, not at all.
Yeah.
It is this process of trying to take an inherently human object, like a novel or a textbook, and forcing it into this very strict digital hierarchy.
Okay, let's unpack this, because we aren't just going to sit here and read through lines of Haskell code today. We are going to look at how a programmer's initial attempt to build this text-to-ebook parser accidentally exposes a massive blind spot in our everyday understanding of a book's architecture.
It really does.
Because to build a system that works, you really have to understand the anatomy of the content. So where does this specific software project actually begin? Like, how does it manage to get the blueprint of a book so fundamentally wrong right out of the gate?
Well, the notes describe the starting point as this sort of pet project written in Python. It was originally called TXT2 book.
Okay.
And the developers basically reflecting on this early code. They bluntly categorized their own initial attempt at modeling the book's structure as, quote, incomplete or hackish.
Hackish, let me guess. They just wrote a script that, I don't know, scans the document for the word chapter, numbers them 1 through 20, and calls it a day.
I mean, it was slightly more layered than that, but yeah, equally limiting. The original parser was programmed to recognize only 2 types of headers in the entire text, just volumes and chapters.
Wait, really? Just those 2?
Yeah. As far as that early codebase was concerned, a book was exclusively a collection of volumes. And inside those volumes were lists of chapters. And that was it.
Man, going back to that blueprint analogy, that is literally just mapping out the living room and the bedrooms. You acknowledge the primary living spaces, but you just completely ignore the entryway and the perimeter.
Exactly.
If you hand that blueprint to a program, it's going to throw a massive error the second it stumbles across a driveway.
It will. And what's fascinating here is that if you asked a random person on the street to describe the structure of a printed book, they would likely describe it exactly the way this initial parser did.
Yeah, I probably would have.
Right. People just think of a book as a story broken down into chapters. And maybe, like, if it happens to be some massive epic fantasy, those chapters are grouped into volumes.
Which totally feels logical from a reader's perspective. You open the book, you read chapter 1, you finish on chapter 30.
Sure, from a reader's perspective. But systematically, it's a massive structural trap. We have to look at what a volume actually is in this specific data model.
Okay, what is that?
Structurally speaking, a volume is nothing more than a container. It's just a list of chapters. That is its entire function in the digital hierarchy.
Ah, I see.
So if the entire model of your document is literally just containers of chapters, well, that model becomes completely inadequate the moment you encounter any text that isn't part of the core narrative.
Because it doesn't fit in the box.
Yeah.
So the developer realizes the TXT2 book project is hackish because, obviously, a book is way more than just volumes and chapters. So according to the notes, what is the actual traditional structure of a properly formatted book?
So the notes detail this major shift away from the simple volume and chapter binary. Traditionally, a properly structured book is actually divided into 3 distinct groups. In publishing and structural formatting, they refer to these as the 3 matters.
The 3 matters. Okay, let's break those down, because I feel like understanding these definitions is super crucial to understanding why the software kept breaking.
Absolutely. So the first group is the frontmatter. This classification covers absolutely anything that comes before the main narrative begins.
So we're talking like a preface or a foreword.
Yeah, exactly. A preface, an introduction, maybe an acknowledgement page or a prologue. All of that structural content falls under frontmatter.
Okay, got it. And then you move into the core content, right?
The body matter.
Yeah.
This is where your volumes and your chapters actually live. It's the main story, the primary substance of the whole document.
Okay, that's 2.
And finally, you have the third group, which is the backmatter. And this is strictly defined as anything that happens after the main story officially
So
concludes.
like an afterword.
Yeah, an afterword, an appendix,
Uh,
a glossary, a bibliography.
or an epilogue.
Okay, front matter, body matter, back matter. I hear that, and structurally it sounds very clean.
Yeah.
The porch, the house, the backyard. But, so, what does this all mean?
What do you mean?
Like, if I'm writing a parser to turn a text file into an ebook, why can't the computer just treat a preface as chapter 0? Or, treat a glossary as chapter 50? Why invent 3 separate structural categories when you could just number everything sequentially and let the e-reader sort it out?
Well, forcing everything into a sequential chapter list is exactly the kind of workaround that creates cascading errors in software. Let's trace the logic of treating a preface as chapter 0.
Okay.
Remember the rule of the initial parser. A volume is a container that holds a list of chapters.
Right. Every chapter has to live inside a volume.
Exactly. So if the parser scans the text, identifies the preface, and tags it as chapter 0, the compiler instantly asks, okay, which volume does chapter 0 belong to?
Right. The parser attempts to stuff the preface into volume 1. But structurally, a preface doesn't belong to volume 1. A preface introduces the entire book. It actually sits outside the volume structure entirely.
Yeah, if you force the preface into the chapter box, you are basically telling the computer that the front porch is located inside the living room. It totally breaks the spatial logic.
It creates a paradox.
Yeah.
The structural epiphany hidden in these programming notes is that front matter and back matter fundamentally need to be treated on the exact same hierarchical level as volumes.
Wait, really? The same level?
Yes. They are peers. So it's front matter, volume 1, volume 2, back matter. They sit side by side at the very top of the document tree. If the parser treats front matter as a subordinate element to a volume, the whole digital model collapses.
Because it's nesting things that shouldn't be nested.
Exactly. The software will perpetually miscategorize where sections begin and end, because the nested logic is fundamentally flawed.
That is a massive architectural shift. You go from seeing a book as just a single bucket of chapters to seeing it as this complex compound with distinct equal-level zones. So how does the developer actually translate that realization into functioning code?
So the solution they came up with involves throwing away those rigid chapter parsers entirely. Instead, they introduce a brand new data type in the Haskell codebase, which they name header.
Header, like a generic header.
Yes, exactly.
Let me play this out. Instead of writing a specific block of code that says, hey, if the title is preface, put it in the front matter bucket, and then another block that says, if the title is epilogue, put it in the back matter bucket, they basically bypass all those tedious exceptions.
They have to. Writing endless IFIL statements for every possible book section, prologues, forewords, glossaries, indexes. I mean, it would be a nightmare to maintain. It's incredibly fragile code.
Right, because someone's going to invent a new section you didn't think of.
Exactly. The brilliance of the header data type is its generic simplicity. The generic header parser caters to all 3 of the matter groups by focusing on just 2 specific pieces of information: the level of the header and the title.
Just level and title. But wait, how does the code actually know where to put a piece of text if it doesn't care what the word prologue means?
It relies on sequential parsing. The computer reads the text file from top to bottom. It doesn't actually need to know the literary definition of a prologue. It only needs to know that this header is a, quote, level 1 header.
Oh, I see.
Right? A level 1 header dictates a top-tier structural container. So the parser opens a new container, it notes the title, say prologue, and just drops all the subsequent text inside.
So it's mapping the hierarchy on the fly based purely on the weight of the header.
Correct. As the parser continues down the page, it might eventually hit a level 2 header titled Chapter 1. Because it is level 2, the parser knows this element is subordinate.
So it puts it inside the bigger box.
Yeah, it must be nested inside the currently open level 1 container. The code no longer stresses about whether something is technically front matter or body matter. It constructs a perfect, multi-tiered document tree just by tracking when a level 1 container opens, what level 2 items fall inside it, and when the next level 1 container begins.
That is such a classic aha moment. By zooming out and making the rules more generic, they actually solved a highly complex categorization problem. The developer realized that to handle the infinite variations of how humans structure books, the code couldn't afford to be super specific. It had to be foundational. Header just catches everything in one elegant net.
In theory, yes.
Yeah.
The header solution is incredibly elegant. But in practice, the notes pivot to reveal an entirely different story.
Uh-oh.
Yeah, while the architectural theory is pristine, the reality of implementing it into the existing code base is, well, it's pretty chaotic.
Wait, really? You figure out the perfect logical blueprint. Shouldn't typing it into the compiler be the easy part?
I mean, if you are building a new application from scratch, perhaps. But the context here is a migration. The author is not writing a new program in a vacuum. They are actively porting a script, a specific file called parser.hs, over to a completely different environment, a console application named X2 ebook.
Ah, they are ripping the wiring out of an old house and trying to force it into a new one.
And the voltages don't match. The notes detail some severe friction points during this porting process. When developers compare the old code to the new code, what they call looking at the diff, it is visually jarring.
Like it doesn't even look like the same program.
Basically, the author complains about mismatched naming conventions and clashing coding styles between the original script and this new console app architecture.
It's a messy transition, but wait, isn't Haskell supposed to be this incredibly rigorous mathematical programming language? I thought the whole point of using it was to prevent messy code.
Well, if we connect this to the bigger picture, Haskell's strictness is actually part of the friction here. Haskell is a statically typed functional language. It is notorious for demanding absolute precision with data types.
Okay.
In a language like Python, where the original TXT2T book was written, a string of text is generally just a string. You can manipulate it, pass it around, and the language is fairly forgiving.
And Haskell isn't.
Haskell is absolutely not forgiving. It demands you explicitly define whether you are working with a standard string, a byte string, or strict text every single time.
Oh, wow. Which means porting a tool that specifically handles massive amounts of text, like, a book parser, is going to trigger endless errors if the types don't match perfectly.
Exactly, and the author explicitly acknowledges this reality in the notes. To get the XS2 ebook application to compile without rewriting everything from scratch, they rely on a specific Haskell extension called overloaded strings.
Overloaded strings, that sounds like they are forcing the compiler to carry more weight than it wants to.
That's a good way to put it. It acts as a bypass. The extension basically allows the developer to write string literals without explicitly defining their type every single time. It forces the compiler to infer the correct type based on the context.
Okay, so it saves time.
It saves an enormous amount of time during a messy port, but the author openly admits its technical debt. They state their intention to eventually remove the extension and rewrite those sections properly in the future.
They are duct taping the pipes just to get the water flowing, knowing full well they have to come back and solder them later.
Pretty much. And they go even further. The notes confess that in the current build of XE ebook, there is blatant code duplication between the volume and chapter parsers.
Wait, code duplication. That is practically a cardinal sin in programming, isn't it? Like, the entire philosophy is don't repeat yourself, keep the logic centralized and clean.
Oh, the developer knows it's a violation of best practices. They explicitly log it as something to refactor in a subsequent update. But I think it highlights a really fascinating tension in software engineering. Well, we often conceptualize programming as this pure mathematical exercise, where brilliant logic flows flawlessly into a terminal. But the reality is profoundly pragmatic. The developer solved the theoretical problem, the three matters, and the generic theta. But getting the console app to actually execute that theory meant compromising on style.
The priority wasn't writing a beautifully clean script. The priority was simply getting the parser to read the headers correctly so the document tree wouldn't collapse. They chose functional structure over pristine syntax.
Progress over perfection. They established the load-bearing walls first. The duplicated code and that overloaded strings extension are really just scaffolding left on the building. They serve a temporary purpose, and they can be stripped away later once the core architecture is proven to hold weight.
Man, that is so interesting. Let's synthesize this journey because I feel like it really pulls back the curtain on how complex digital translation actually is. We started with the original Python project, right? Which operated on a very human but deeply flawed assumption that a book is just a list of chapters inside volumes.
Right. A model that inevitably crashes the moment it encounters a preface or an appendix because it forces external elements into internal containers.
Exactly. And from there, the notes revealed the hidden architectural reality of the three matters: frontmatter, bodymatter, and backmatter. We realized that a prologue isn't just an extra chapter. It's a fundamentally distinct structural element that sits on the exact same hierarchical level as the core volumes themselves.
And to solve that hierarchy problem, the developer abandoned those specific rigid rules They zoomed out and created the generic fetter data type. By reducing the parsing logic to just level and title, and reading the document sequentially top to bottom, the code could dynamically construct a perfect digital model of the book.
Without even needing to understand the literary difference between a foreword and an epilogue.
Exactly.
Even if the actual implementation of that elegant solution, porting the script into the new application, resulted in a temporary mess of technical debt, mismatched conventions, and reliance on extensions like overloaded strings just to bypass Haskell's strict typing.
Yeah, the underlying logic held up, even if the syntax was temporarily compromised.
So why does this matter to you listening right now? Because it demonstrates that properly organizing information requires an absolute respect for the anatomy of your content. Whether you are writing a Haskell script to parse an ebook or, I don't know, you're just structuring a massive quarterly report for your team, you cannot just force complex information into a flat bulleted list and expect it to make sense.
You really can't.
You have to understand the hierarchy. You have to know which elements are containers, which elements are subordinate, and which elements sit completely outside the main structure entirely.
It really all comes down to structural integrity. Consider this the next time you hold a physical book. Flip to the glossary or the introduction. Human beings intuitively understand that these sections serve a completely different mechanical purpose than the main narrative. We don't need to be told how to interact with them.
No, we just know.
Right. But a computer must be painstakingly taught the architectural difference between the story and the framework supporting the story. Makes you wonder, what other intuitive human structures are we currently failing to properly define for the digital systems we rely on every day?
Wow. Are we building software houses with no front doors simply because we forgot to mathematically define how a human actually enters a building? It is an incredible question to chew on. Thank you for joining us on this deep dive. Stay curious, and we will catch you on the next one.